Hi Yogesh.
Hello, Sonika.
As you already know, we are here to discuss on a project on which we are currently working on, which is ESP hosted. Basically, I'm working on a solution where I want Wi-Fi connectivity on my Linux-based host, but I don't have Wi-Fi controller on it. So, could you please help me to understand how ESP hosted will fulfill my requirement?
Definitely. So, I think you have come to correct place. So, ESP hosted can actually give your connectivity solution. Overall, in the market, in the ESP chipsets are actually used as a microcontroller or MCU, a standalone MCU. Here in ESP hosted, we are not using as a standalone one. So we are introducing one different mode, which is a communication coprocessor, within which we are actually attaching ESP chipset to your Linux SoC so that you can get the Wi-Fi connectivity on your chipset.
Okay, so communication coprocessor, that sounds interesting. So, but I'm a little bit confused here. So, can you please tell me, like, how can I directly get Wi-Fi connectivity on my host? I mean, how is that possible? So, if you can explain in detail, it will be really helpful.
Definitely. So, but first I will try to give you some brief what is ESP hosted, and then we can discuss that. So, overall, ESP hosted is an open source solution that provides a way to use Espressif modules as a communication coprocessor. This solution provides Wi-Fi connectivity like Wi-Fi and Bluetooth to host microprocessor or microcontroller, allowing it to communicate with other devices. This solution can be used with both RTOS based and the Linux based systems. In this solution, there are two different variants. One is ESP hosted NG, that is next generation, and another one is ESP hosted FG, which is a first generation. So I will just try to dig little ahead, and we will, as you are using the Linux based device where you want to get the ESP hosted, I will just go to the next generation. Can you see the block diagram here?
Yes.
So overall, I will try to explain this block diagram. In this, you can see there are two major parts. One is the down part, which is ESP chipset, and the above part is Linux host. And you can see the legends in the bottom. The yellow colored components are ESP IDF components. In the blue color, ESP hosted NG components are there. Basically, ESP hosted software will be in the blue color. And the gray color is for the third party components. Basically, these are the components we are going to use it, but we are not going to change it.
Okay.
So I'll try to explain ESP part first, and then we will gradually move to the Linux counterpart. In the ESP, you can see the blue colored ESP hosted NG firmware. This is a software, a small software which you need to burn or flash on the ESP chipset. Just down, you can see two components, that is ESP Wi-Fi driver and ESP HCI driver. These two components are used from the ESP IDF, and they are used as is, so there is no change as such. Now we will try to go little up towards the Linux. You can see there is a standing line or arrow in between ESP and Linux host. And just above that arrow, bus driver, SDIO, SPI, or UART. So what I mean to say is ESP and Linux are connected with SDIO or SPI or UART or combination of these. We call this as a transport combination. Now we will try to understand the Linux host part. Overall, Linux is divided into two parts. One is the kernel space and another is the user space. The user space is more of used for the user applications, and the kernel space we will have the kernel driver here. Right. In the user space, you can see there are three legs. First is the WPS applicant, second is the networking applications, and third one is the Bluetooth. I will try to focus on the WPS applicant first. WPS applicant is a standard software which is run on general all the Linux based systems. This software is actually used to get Wi-Fi connection working on your Linux.
Okay.
So whenever you're starting your system, this WPS applicant by default will be running on your Linux. Will be communicating the underlying nodes like libnl in the user space itself, then going to NL 802.11 in the kernel space, interacting with the CFG 802.11, and then communicating with the ESP hosted ng driver. Now let us stop here. This vertical line, we are seeing that WPS applicant, libnl, and so on and so forth till CFG 802.11. These are all grayed or gray color. These components are as is used. We are not changing anything out of it. Now we will resume that when the WPS applicant is up, it will try to get the Wi-Fi working. So with the configuration it has, it will communicate till CFG 802.11, and you can see the blue colored ESP hosted ng driver, which is actually integrated with CFG 802.11 APIs. Now, whenever the request comes from the WPS applicant, it will enter into the ESP hosted ng driver, and following ahead, it will go through the bus driver like SDIO, SPI, UART, the peripherals we are connected. It will enter into the ESP hosted ng firmware.
Okay.
So ESP firmware, and below it ESP Wi-Fi driver is actually whenever the request is coming for Wi-Fi related needs, it will communicate with your AP and get it back whatever the response we have got till Wi-Fi WPS applicant.
Right.
So this is overall how the Wi-Fi or WPS applicant actually tries to configure something. It will travel this path. Now, once this WP supplicant has got the Wi-Fi active Wi-Fi connection, there is a one new network interface which we are going to introduce. That is going to be ESP star 0, for example. That will be used ahead. I will just tell you. So in the second leg, in the standing second leg, you can see the networking applications. So this networking application, you can assume it as a kind of something socket or something being run in the user space. Now it is going to it wants to transfer something on top of TCP/IP stack. So now your ESP star 0, which we had got up, whenever you're transferring, it will go through that network interface, end up in the ESP hosted ng driver, and the path remains same. It will follow through till Wi-Fi driver. It will go to the Wi-Fi, and back and forth the data transfer happens. So you could understand. So I just wanted to highlight the WPS applicant leg is for the controlling of the Wi-Fi. The networking application is the data path, what we are talking about. Now third leg, which is last leg in this slide, is Bluetooth applications. We have Bluetooth control utility, which is given by the Blues itself, which runs in the user space. Using the whenever we are trying to communicate with Bluetooth, this utility will in turn communicate with Bluesy core, which lies in the kernel space, and that particular will communicate with ESP hosted ng driver, and the communication will go further down. It will end up in ESP hosted ng firmware. Here it will take another path, ESP HCI driver,
Right.
and it will communicate with the using the ESP chipset's Bluetooth controller. It will communicate with your other devices of Bluetooth. So this is overall how the Wi-Fi and Bluetooth comes in picture, how they are communicating over the ESP hosted software.
Okay, so here I can see Wi-Fi and Bluetooth both are supported by ESP hosted. So can I use it simultaneously?
Yes, so overall ESP hosted software was designed such a way that it was expected to be coexistent, like Wi-Fi and Bluetooth both will be working at the same time. So you can, and by default the settings are like that. Wi-Fi and Bluetooth will be exposed, and you can directly use it out of it.
Okay. So from this block diagram, what I have understood is like blue color components are ESP hosted components, which we are using for connectivity, and all gray color components are the services which are provided by Linux host, right?
Yes, interestingly, that is the main point. So Overall, all the gray colored components are not touched upon or not modified anything out of it.
Okay.
We are only introducing the blue colored softwares. In the Linux space, it is a kernel module. You just have to uh, you just have to install it in your Linux system or insert it in Linux system, and that's all. You don't have to do anything other than that in Linux subsystem. With that, you should get the wireless connectivity solutions easily.
Okay, I think Yogesh, this is so much informative. So if you could give me some practical example, it will be really helpful to understand it practically.
Now I will try to take you to a demo so that you will understand how things are done and how easily it could be done. So when we try to Google ESP hosted, you can see there is a ESP hosted repo. And I'll just try to go through the repo. So this is the repo, how it looks like. I will just move to the detailed documentation, and here we will go in the setup. So overall, there are multiple combinations available: transport layer, SDIO, SPI, and UART, combination of those. Right now, we will just try to look at SPI because it is my devices are connected with the SPI right now. And these all combination transport combinations are detailed enough. In the right side, when you expand, you will get to know all the details. Now this is SPI demo we are talking about. You can see in the left side the Linux subsystem will be sitting. Here we have taken Raspberry Pi as an example. In the right side, there is a ESP32. It could be any variant like Room or any other ESP32 variant you can use. These are the pin combinations actually above here are connected. Now this pin configuration, the pin length of the jumper cable should be minimal enough. We are suggesting it to be less than 10 centimeter.
Okay.
Let's go to the software counterpart. In the software setup, first thing we need to do is load the ESP binaries, basically flash the ESP firmware. So these where this firmware comes from. So we have already have releases where we are giving the binaries which you can easily flash. So I'll just download this, and let's go to the terminal so that I can flash that. So I have gone into the repo, the releases. I will just show you what are the files here. ESP32. Here, if I do ls, you can see all the transport combinations are the binaries for these all are present here. Right now we will focus on SPI. Now you can see there are many files here, binary files, and there is flashing command.txt. We'll just cat that file, copy paste the command, and change the two things here. One is the flash baud rate, basically the baud rate at which the flash should happen, and we'll change the serial port. This is the port where ESP is identified to your system. Here, so the flashing has started, and it is just one command that you need to trigger to get the flashing done.
Okay.
As you can see, it is already flashed now. Now we will go back to the documentation. This is not needed now. I'll just close. We have covered this ESP binaries flashing. Now we will go to the Raspberry Pi configuration. So this configuration below is specific to the Raspberry Pi, and these are only one-time needed activities, and that is already present in my setup. So we can just move ahead with this. Okay, so this is the GitHub repo where we are right now. We need to clone. This is already cloned, so we'll go to the build and load kernel module. This is the important part. Here, the WP supplicant by default will be up on your system, but it can interfere our testing, so we'll just try to kill it first.
Okay.
So I'll go to the Raspberry Pi. Let's try to kill it. Now we need to go to the repo and fire these commands. So this is rpinit.sh is actually a bash script which is for building the kernel module in the Linux system and inserting it. When we insert this module, it will create a ESP star 0 interface, which is network interface, which is compatible with 802.11. So once this is done, we will check ifconfig and iwconfig to verify the interface is created or not. Just allow one moment. So ifconfig, if I do, see, these ESP star 0 is created and you can see it is up. It doesn't have IP address. I'll just try to iwconfig. And here ESP star 0 is also there. And you can see, you can notice the it is not connected, not associated. Now we'll go back. So overall this is done. So we will move to the next part, which is actually connecting to Wi-Fi. So I'll jump to this Wi-Fi and Bluetooth over the setup. Here you can see Wi-Fi user guide is there. I will just try to scan existing APs. So it is listing all the APs. I'll just try my AP here. Okay, so it is the AP is hosted WPA2. I created with WPA2 security. So there are two types of modes available. Open mode. Right now we are having WPA2, so I will jump to the security mode WPA2. WPA2 passphrase, we will try to create a configuration which is understandable by the WPA supplicant. So SSID we have to change and the password we have to change. By the way, these commands are standard. So WPA passphrase and we are not giving it anything. It is already available. We will try to start the WPA supplicant. We will try to run it in background. So here you can see the event connected is fired. So it is connected already. Let's verify it. Now you can spot the difference. ESP star 0 has access point listed. So it is already connected and it is connected with the SSID which is hosted WPA2. So this is connected. Let's try to get the IP now. So DHCP we will try. Okay, IP is there. Now I'll just ping. See, so in very less time and very less commands, we are able to get the Wi-Fi up. And this is all about, Wi-Fi subsystem. Now I'll try to focus on Bluetooth also because it will be easier to showcase that. BT, I will try to enter. For BT, you have to do Bluetooth CTL. And we will try to scan the neighboring Bluetooth devices. Okay, so my device, my mobile is actually having the A2DP source. So we will try to exit from this because we need pulse audio because otherwise it cannot go ahead further. So let's exit and pulse audio I will just start. And we will try to rerun the sudo Bluetooth control. Now we will try to scan neighboring devices. So I have my device named as hosted. So it should be scanned here. See, this is my device C2 ending with, but name will also come. Let's see. Okay, this is a paired device already. So I don't want it to be used. So I'll just remove it so that we can create a fresh pair request. It is removed. I'll just pair it. Okay, it is detected as new. Now I can pair it. Yeah. Okay. So I have got the request on my mobile. I'll just accept it. and see the pairing is successful. I'll just try to connect it. Okay, it is failed to connect. Sometimes if the scan is ongoing, this may fail, so we will just stop the scan and retry the connection. Okay, it is connected and the services are resolved, so it is connected now. I will just try to shut it off, the Bluetooth of my mobile, and let's see if it is disconnected or not. I stopped the, yeah, see, momentarily when I switch off, the connected becomes no. So this is so it is momentarily, you can see all the status. This is all about Bluetooth. I'll just show you HCI config, which is a utility. You can understand how is the HCI0 is working. So right now the connection is on the SPI bus, as we have already done it on the SPI.
Okay.
So this is all about the Wi-Fi and Bluetooth getting up in your Linux subsystem.
Okay.
Was it good enough?
Yes,
was it
yes,
easy?
actually it gave me fair idea that how ESP hosted works. So thank you so much for the demo. But here what I have observed that we are using Linux host only, right, for this particular next generation. But what if I have MCU based host and I want Wi-Fi connectivity on it? Then how can I use this solution?
Definitely, I will try to showcase that as well. So this ESP hosted next generation was more focused about WPS applicant, or more focused about the Linux subsystem or Linux devices. Now I will try to show you how the MCU counterpart or MCU host can work with the ESP hosted. So can you see the diagram here? So ESP hosted,
Yes.
this is specific for the ESP hosted first generation. In the previous diagram, it is almost similar to the previous block diagram. You can see the ESP components and the yellow colored, blue colored components are almost same. You can spot the difference. There is a one extra blue colored box in the MCU host side.
Right.
So I'll try to explain in a stepwise manner. So ESP in the bottom, you can see ESP hosted firmware. First generation firmware is there instead of next generation. Below that, ESP Wi-Fi driver and ESP HCI driver. These are same, inherited from the ESP IDF components. It above that, the connections are same transport combinations you can use in the FG and NG and FG. So those are SDIO, SPI, UART, and combination of those. Above it, in MCU host, you can see blue color ESP hosted FG driver, which is basically our software which you can use with the MCU host.
Okay.
Just above it, in the left side, you can see custom control path. Why this this is the main difference in between the FG and NG, that is first generation and next generation. So next generation had WPS applicant in the Linux ecosystem, but in MCU host we do not have WPS applicant running or anything like that. So what approach we tried to do is we introduced our own custom control path, basically some APIs that could be easily integrated with your networking application. Through the control path, you can actually invoke those APIs, and for example, one function with SSID and password, and that is invoked, then it will translate through the down and will get connected to your actual AP with that SSID and password. So overall control path will try to get you the connection of the Wi-Fi. Once this control path is done, the data path in the right side, you can see the networking application can push some data or any throughput or anything data. It will go through the TCP/IP stack. Again, same path, it will translate and to the ESP IDF components and will try to push the data and back and forth. So I hope this is clear, understood properly.
Yes, so I can spot main two difference over here. So for next generation, it is basically used for Linux based host, and first generation is for MCU based host. And custom control path which you have mentioned. So in Linux based host we have WPS applicant for getting Wi-Fi connectivity and all, and so in first generation we have custom control path, right? So
Perfect.
okay,
Yes.
so what other differences are there? I mean, are there any other differences in between two variants?
Okay, so I will just try to show you what all the possible differences are existing in the system. So this is the overall comparison of the FG, like first generation and the next generation.
Okay.
So in the left side you can see ESP hosted first generation, and in the right side you can see ESP hosted next generation. And I will just try to go through this list feature by feature. So supported platforms on the first generation, those are MCU and Linux host, and in the next generation there is Linux only host.
Okay, so Yogesh, hold on here. So I can see Linux host is supported by both the solution. So what is the difference then? I mean, if I can use Linux host in both the cases.
Okay, that is good. I was expecting this question. So first generation is usable by the MCU and the Linux host both. If you remember, in first generation we had a custom control path which was usable by the MCU and Linux host both, so they can both use.
Okay.
But in the next generation, because it is 802.11 what you say configuration or WPS applicant based configuration, you can only use with the Linux ecosystem. Okay, so this is custom control path. Even though it is usable in MCU, it could be usable from the Linux as well.
Okay.
Understood. So I'll just go to the next items. Wi-Fi configuration mechanism. So here, as we discussed, in first generation, we are giving the custom control interface or control path to connect it with your Wi-Fi. And in case of next generation, it is NL802 or CFG 802.11 based or WPS applicant based connection.
Right.
In the network interfaces available, basically after inserting the module, these are the exposed type of Ethernet interfaces what we are talking about. In the first generation, we expose 802.11, 802.3 Ethernet interface in case of first generation. But in case of next generation, we expose the 802.11 Wi-Fi interface. Basically, why? Because we want to configure it through CFG 802.11.
Mm-hmm.
The next line, we were talking about how it is MCU and Linux. So although it is the first generation is supported by the MCU and Linux host, you see the recommended host type, we are mentioning it here as MCU host for first generation, and in the next generation we are talking about Linux host. Okay, so CFG 802.11 or WPS applicant way makes it seamless way for Linux ecosystem.
Got it.
Okay. The coming up next is Wi-Fi features. We are supporting 802.11 BGN in case of both. The transport layer, as we discussed, remains the same. The transport combinations also remains the same, which are based on the SDIO, SPI, and UART. The Wi-Fi mode, in case of first generation, they are supported as station mode and soft tapping mode. But in case of next generation, we are supporting station. In case of Wi-Fi security protocols, we are supporting Open WPA, WPA2, and WPA3 in case of first generation. In case of next generation, we are supporting Open, WPA, and WPA2. For Bluetooth, we are supporting Classic BT, BLE 4.2, and BLE 5.0 in case of first generation. In case of next generation, we are supporting Classic BT and BLE 4.2. When we come to chips which are supported for these solutions, for first generation, we support ESP32, ESP32C3, ESP32S2, ESP32S3. And in case of ESP hosted next generation, we are supporting only ESP32. I will just come to important part, which is IPUF throughput. So overall, the data path remains the same for both of them. So we have achieved 25 Mbps in case of RX and TX, both the cases.
Okay, so one more thing here, I can observe that first generation variant supports more features than next generation. So do you have any plan to support this in next generation, these features?
Actually, So first generation we have developed already, and
Okay.
so we wanted to have the experience of the seamless way. So 802.11 is the next generation we have recently developed. So the missing features in the first, in the left side, basically from the first generation, like soft AP Wi-Fi mode, or WPA3 security protocol, or BLE 5.0, or the chipsets which are supported already in the first generation are going to be supported in next generation in the phase wise manner or the release manner.
Okay.
So on top of it, so apart from these features, we are planning to go ahead and plan next features as well. I'll just try to show you what are the next upcoming feature set will be.
Okay.
So what next? The next features are Wi-Fi 6 support, the BLE 5.2 support, USB support, 802.15.4 support, basically through the thread. And the next ESP chipsets which we are going to support in future are ESP32 C2, C6, C5, and H2.
Okay. Uh, one more thing, like, can you tell me what are the application for this ESP hosted, or who are the target customer for this?
Definitely. So when you talk about the ESP hosted, there are two ways how the solution can be integrated in your solution. You can have already developed your system or software, like a say legacy system. I'll just try to formulate example. Consider vacuum cleaner that you have already developed, and you want now you cannot change it, already developed solutions. So you can just attach ESP chipset to that particular SoC or the chipset, and get the ESP hosted integrated with it, and you can actually make that cloud connected or connected that particular system. So this is the one way of looking at. Other way, we can embed integrate the ESP hosted when you are thinking about creating new solution from the scratch. So whenever you're anyway, you will need the Wi-Fi or Bluetooth connectivity in your solution.
Right.
So from the start, you think that you are going to use ESP hosted so that you can really focus on only your business logic with what you are going to develop. So this way, these two ways, both the ways, you can integrate your solution and you can benefit out of it.
Right, right. Okay. So one last question. So
Okay.
suppose I want to integrate this ESP hosted with my solution, and if I will face any issue, so will there be any help provided? I mean, how can I get resolve my queries?
Understood. So we have given the troubleshoot document that is already present in the repo itself.
Okay.
And ESP hosted is a open source solution. So this repo or the issues are already visible for you publicly. So even if you are facing any issue that must be faced by somebody else already, so you can find out through those issues. And even if it is new, just raise a what do you say issue on the GitHub repo of ours, and we will definitely help you out there.
Oh, that's great. Okay. So thank you so much, Yogesh, for the detailed presentation, and what is for explaining what is ESP hosted. So it is really helpful. Thank you so much.
It was all my pleasure. Thank
Thank
you.
you.
Thank you, Sonika.